Good day, MS Mathematics. I am Mary Archie Seroje and I am the last reporter of Group 8 and I'm going to discuss about chi-square test. Chi-square test. For our lesson objectives, we are going to define test of independence and test of homogeneity, to define contingency table, to identify the procedures for chi-square test of independence and test of homogeneity, to determine the critical value using chi-square table, and to solve for the chi-square test of independence or homogeneity. Test of independence or homogeneity. For test of independence, this tests the null hypothesis that there is no association between the two variables in a contingency table where the data is all drawn from one population. For our test of independence, our null hypothesis, which is H sub O, such that X and Y are independent. This means there is no association between two variables. For our alternative hypothesis, H sub A, X and Y are dependent. There is an association between two variables. Next is the test of homogeneity. This tests the null hypothesis that different populations have the same proportions of some characteristics. The key difference from the test of independence is that there are multiple populations that the data is drawn from. For our null hypothesis, proportion 1 is equal to proportion 2 is equal to up to proportion sub n, wherein the proportion of X is the same in all the populations studied. For our alternative hypothesis, at least one proportion of X is not the same. This means at least one of the proportions of X differs from each other. Contingency table. It is a table that lists the frequency of occurrence for categories of two variables, wherein in the rows are the first variable and in the columns are the second variable. We have three requirements for test of independence and homogeneity. Number 1, sample data are randomly selected. Number 2, for each cell in the contingency table, the expected frequency E sub I is greater than or equal to 5. And number 3, individual observations must be independent, meaning no distribution requirement. These are some questions in problems including test of homogeneity and test of independence. Is the proportion of X the same in all the populations? Is the proportion of X different in at least one of the populations? Does one of many processes under evaluation have a higher proportion of X? Are X and Y dependent? Are X and Y independent? Is there a relationship between X and Y? For both of the tests, test of independence and test of homogeneity, other than the hypothesis, all the procedures are the same. This means that whatever procedures we are going to do in test of independence, it's just the same with the test of homogeneity, other than the hypothesis. Let's have the steps. These are the procedures for chi-square test of independence or homogeneity. Step number 1. Set up the hypothesis for the chi-square test of independence or homogeneity. Step number 2. Determine the degree of freedom, level of significance, and critical value or region. For the degree of freedom is calculated by using the following formula. df, meaning degree of freedom, is equal to number of rows minus 1 multiplied to number of columns minus 1. Step number 3. Compute for the expected frequencies. The formula for expected frequency is equal to row total multiplied to column total all over total sample size. This is the chi-square distribution or chi-square table. This is used to give the critical value or to get the value of the critical region. Let's proceed to step number 4. Compute for the value of chi-square test of independence or homogeneity using the formula x squared is equal to summation of quantity observed value minus expected value raised to 2 all over expected value, where x squared is the chi-square value or the x squared computed, and O is the observed value, and E is the expected value. Step number 5. Statistical decision for hypothesis testing. If x squared computed is lesser than x squared critical, we are not going to reject the null hypothesis. If x squared computed is greater than x squared critical, we are going to reject the null hypothesis. Last step, state the conclusion. Let's have an example for test of independence. Suppose that a survey has been undertaken to determine if there is a relationship between place of residence and automobile preference. A random sample of 150 car owners from urban and 100 from rural areas were selected with the following results below. At the 0.05 level of significance, is there evidence to reject the claim of a relationship between place of residence and automobile preference? We are going to use the test of independence since we are going to test the relationship between place of residence and automobile preference. So this is the given data. Step number 1. State the hypothesis. For our null hypothesis, there is no relationship between place of residence and automobile preference, and this is the claim. For our alternative hypothesis, there is a relationship between place of residence and automobile preference. Step number 2. Determine the degree of freedom, level of significance, and critical value or region. Our level of significance is equal to alpha, which is equal to 0.05. And to determine the critical region, we are going to solve first the degree of freedom, which is equal to number of rows minus 1 multiplied to number of columns minus 1, which is equal to 2 minus 1 multiplied to 4 minus 1, and the answer is 3. Using the level of significance alpha 0.05 and the degree of freedom 3, we are going to locate the critical value in the chi-square table, and the x-squared critical value is equal to 7.815. Step number 3. We are going to compute for the expected frequencies. Given the data, we are going to multiply first the first row total, which is 150, and the first column total, which is 105. First row total 150 and first column total 105 all over the 250, which is the total, which is equal to 63. Next, the first row total 150 multiplied to the second column total, which is equal to 60, all over 250 is equal to 39. Next, first row total 150 multiplied to the third column total 35 all over 250, which is equal to 27. Next, first row total 150 multiplied to the fourth column total, which is 30, divided by 250 is equal to 21. Next, for the rural area or rural residence, we have the second row total of 100 multiplied to the first column total 105 divided by 250 is equal to 42. Next, second row total 100 multiplied to the second column total 60 divided by 250 is equal to 26. Next, second row total 100 multiplied to the third column total 35 divided by 250 is equal to 18. And lastly, first row total multiplied to the fourth column total of 30 divided by 250 is equal to 14. Step number 4. Compute for the value of chi-square test of independence or homogeneity. So we are going to create first an expected frequency table. So this data here is based upon our answers in step 3. So let's solve for the value of chi-square test of independence. So we have here the formula. X squared is equal to summation of observed value minus expected value squared all over expected value. Let's have first the first observed value of 65. This one. 65 minus 63 squared all over 63 plus 45. This one. Minus 39 squared all over 39 and so on. Next, x squared is equal to 65 minus 63 is equal to 2 and squared all over 63. 45 minus 39 is equal to 6 and squared all over 39. 15 minus 27 is equal to negative 12 squared all over 27 and so on. Next, x squared is equal to 2 squared 4 over 63 plus 6 squared is equal to 36 then over 39. Next, negative 12 squared is equal to 144 over 27. 4 squared is equal to 16 all over 21. Negative 2 squared is equal to 4 over 42 plus negative 6 squared is equal to 36 over 26. 12 squared is equal to 144 over 18. And lastly, negative 4 squared is equal to 16 over 14. And add them all to have the value of x squared, which is equal to 17.705. Step number 5. Statistical decision for hypothesis testing. Our x squared computed is equal to 17.705, which is compared to our x squared critical, which is equal to 7.815. As you can see, x squared computed is greater than x squared critical. Therefore, we are going to reject the null hypothesis. For our decision rule, since the computed x squared of 17.705 is greater than the x squared critical value of 7.815 at level of significance of 0.05, the statistical decision is to reject the null hypothesis. Step number 6. State the conclusion. Since the null hypothesis has been rejected, we can conclude that there is evidence that shows significant relationship between place of residence and automobile preference. Let's have an example for test of homogeneity. The vice president of a large supermarket chain wished to determine if her customers made a list before going grocery shopping. She surveyed 288 customers in 3 stores. The results are shown here. At 10% significance level, test the claim that the proportions of the customers in the 3 stores who made a list before going shopping are equal. So we are going to use the test of homogeneity since we are going to test the proportions of the customers in the 3 stores. Step number 1. State the hypothesis. For our null hypothesis, proportion sub 1 is equal to proportion sub 2, which is also equal to proportion sub 3, and this is the claim of the vice president. For our alternative hypothesis, at least one proportion differs from the others. Step number 2. Determine the degree of freedom, level of significance, and critical value or region. Our level of significance is equal to alpha, which is equal to 0.10. To determine the critical region, we are going to solve first for the degree of freedom, which is equal to number of rows minus 1 multiplied to number of columns minus 1 is equal to 2 minus 1 multiplied to 3 minus 1, and the answer is 2. To get the value of the x-squared critical value, use the level of significance and the degrees of freedom and locate it on the chi-square table. Therefore, our x-squared critical value is equal to 4.605. Step number 3. Compute for the expected frequencies. Let's have first the first row total and multiply to the first column total. So 219 multiplied to 96 all over 288 is equal to 73. Then first row total 219 multiplied to second column total of 96 divided by 288 is equal to 73. Next, first row total 219 multiplied to the third column total of 96 divided by 288 is equal to 73. Next, let's have the no list. Second row total of 69 multiplied to the first column total of 96 divided by 288 is equal to 23. Next, second row total of 69 multiplied to the second column total of 96 divided by 288 is equal to 23. And lastly, second row total of 69 multiplied to the third column total of 96 divided by 288 is equal to 23. Step number 4. Compute for the value of chi-square test of independence or homogeneity. Before we proceed with this solving, let's create first the expected frequency table. Again, this data here is based upon our answers in step 3. So, let's proceed in solving for the value of chi-square test of independence. X squared is equal to summation of observed value minus expected value squared all over expected value. 77, which is the first observed value, minus 73, the expected value, squared all over 73, plus 74 minus 73 all over 73 plus 68 minus 73 squared all over 73 plus so on. X squared is equal to 77 minus 73 is equal to 4 squared all over 73 plus 74 minus 73 is equal to 1 squared all over 73 plus 68 minus 73 squared is equal to negative 5 squared all over 73 and so on. Then x squared is equal to 4 squared 16 over 73 plus 1 squared is equal to 1 over 73 plus negative 5 squared is 25 over 73 plus negative 4 squared is equal to 16 over 23 plus negative 1 squared is equal to 1 over 23 plus 5 squared is equal to 25 over 23. Add them all to have the result of the x squared computed, which is equal to 2.401. Step number 5. Statistical decision for hypothesis testing. X squared computed is compared to x squared critical. The value of our x squared computed is 2.401 and the value of our x squared critical is 4.605. As you can see, x squared critical is greater than x squared computed. Therefore, we are not going to reject the null hypothesis. And for our decision rule, since the x squared critical value of 4.605 is greater than the computed x squared of 2.401 at level of significance of 0.10, the statistical decision is to accept the null hypothesis. Step number 6. State the conclusion. Since the null hypothesis was not rejected, we can conclude that there is no difference in the proportions of the three stores. This time is your assessment. For number 1, a sample of 340 randomly selected people in their 20s were asked about their favorite place to go on a Friday night. The results are given in the table together with the person's gender. So test at a 5% level of significance whether the preferred activity depends on the gender. For number 2, a local college recently made the news by offering foreign language speaking dorm rooms to its students. When questioned at another school, 50 students from each class responded as shown. At 5% level of significance, is there sufficient evidence to conclude that the proportions of students favoring foreign language speaking dorms are not the same for each class? Thank you and God bless everyone. So you may submit your answers through my messenger, Mary Archie Seroje LPT, and Gmail account, serojeMaryArchie@gmail.com. Thank you and God bless.